In this session, we're going to take a look at how we can use pointers to functions for instruction processing. So here we're going to use the same 5 basic steps we used for implementing a menu system using function pointers. So we're going to start first by taking a close look at what each of the functions that we're going to implement have to look after. So choose one of the instructions that you're going to have to implement and figure out what basic information you're going to need to provide that function in order to do its task. So what information is it going to need? What information does it have to pass back? And once you've thought about that, and take a look at a couple of different instructions first, but figure out what the name of it would be, what it would return, and what information you're going to have to pass in. Then, just as we did with our menu, we're going to replace the name of the function with a pointer to a function. So the output remains the same, the return value. Here we had 3 input values, and we've simply replaced the name of the function with our pointer to a function. Second thing we need to do is to create that structure. So both the template, as we have defined here, and then the array with the actual information. So let's take a look at what we have here. We started with a byte that's going to hold the actual operation. So here we can see that first field has hexadecimal bytes that represent the operations that we're going to simulate. Second thing is the name of the function that's going to handle that. So here we have a function. We're going to have a function called LDAA, another one called STAA, and a third called AND-A. Next thing is an integer that holds the number of bytes. So that would be the total number of bytes that instruction requires. So here, our next field has the number of bytes. Then we have the addressing mode and the source. So here we have the addressing mode, immediate, extended, and immediate. And finally, the source, so the information is coming from memory, from a register A, or from memory. So 5 fields, 5 sets of data. The third part, we're now into the actual code. So as you remember from before, we can figure out how many actual instructions we have in our database by taking the size of process, which was the name of my array, and divide it by the size of one element. So number of instructions is going to tell us how many things or functions we've actually specified in our structure. Now, here our first instruction is similar to where we ask the user to pick a menu. So here we're going to get the operation. So we may be getting that from some machine code somewhere. We may be getting it from the user. In any case, OP, or operation, will now have a number from 0 to something less than the number of elements we had. So it needs to be somewhere between 0 and 1 less the number of instructions. So what we're going to do here is we're going to loop from 0 to 1 less than the number of instructions, and we're going to say if our operation is equal to the byte that we specified. So this is a field inside our function now, so process is our array. We're saying element number 0, and we're looking at the operation field. So we're saying, and let's say the user entered 86, which I remember was in our structure. So if 86 is equal to the operation, then we're going to call the function. So here's the call. So we're saying element number I, which would be 0. The funct field gives us the name of the function. And then we're going to pass in each of the fields. So we can see here we have the number of bytes field, the addressing mode field, and the source of the information field. So last time when we were looking at menus, we passed in one string. We can actually pass in as many parameters as we need to for that function. So in this case, if we were choosing I equal to 0, and that's where we found our match, then we're going to call the LDAA function with the number of bytes being 2, the addressing mode was immediate, and the source was memory. So that's what the actual function call would look like. The next step is the easy part, because this is where we're going to write the actual functions. So here we can see the function for LDAA. We remember it was required to return an integer. It expected the number of bytes, an addressing mode, and the source. So in here we have a switch that says if the addressing mode is immediate, then we're going to change register A, we're going to change the program counter, and we're going to set the N and Z bits inside the condition code register. We're going to break from that, and that would be followed maybe a case for direct, a case for indexed, and so on. At the very end, we're going to need to have a return statement, and maybe it returns a 1, indicating that the function was successful. The last step is to define our prototypes. So once we have all our functions written, we can grab that declaration line, move them up into the prototype section. Don't forget to put the semicolon at the end. And finally, a couple of things to keep in mind while you're doing this. First of all, we need exactly the same parameter list for every function that you're going to include. So if one of them needs an extra parameter, you have to include it for all of them. And if you need to do that, then what you would do is set up some kind of a dummy value or a non-valid value that you would recognize is just garbage being passed in. So what you want to do is you want to choose the most complicated one first. So make sure you take a look at all the instructions you have to think about. Indexed addressing, for example, is usually a little more complex to handle than the others. The addition and arithmetic ones are a little bit more complicated than the loads or stores. So take a look at some of the more complicated ones, identify exactly what information you're going to need to do the processing, and use that as your model.